So what is blind plate solving? It's simply a way to be able to identify what's in your images without providing any information at all, especially for people running with a DSLR camera or a mirrorless camera, and there's no FITS file because it's a raw data format that comes out of the camera. There's no right ascension, there's no declination, there's no information in that image. For the built-in plate solver in Siril to be able to identify what is in the image for photometric color calibration, for annotation, a handful of different reasons. The blind plate solver, you simply feed it the image that you want to solve, and without any of that information, it'll tell you what is in that image. And because it's a local plate solver, no internet is required for this to happen. This will help you with your photometric color calibration. This will help you with the images that maybe Cyril's having a hard time solving when you try to do a photometric color calibration. It's a nice tool to have installed. You may not use it all the time, but when you do need it, you'll be happy that you have it sitting there. There's some things we got to go through. You got to figure out your field of view so we can determine which index files you want to download. So let's get to it. My name is Rich, and you're watching Deep Space Astro. Okay, so before we download and install the blind plate solving software, more specifically the index files that we're going to require to do that blind solving, we need to determine what our field of view is for the images that we're going to be solving. The easiest way to do that is to come to astronomy.tools. I'll leave this link in the description below. When you land on this page, make sure you click on imaging mode and then select one of the objects up top here. It doesn't matter what you select. I'll just hit the Lagoon Nebula, but we just need something so it can figure out our field of view for us down here. Start by specifying your telescope. For this example, I'm using my RedCat 51. If your scope is not in this list, then you can just leave it on custom scope and specify your focal length and your aperture manually. Same thing with the camera. So for this particular setup, I use my Canon M50. So we'll just scroll down to EOS M50, and again, it puts in the resolution and the pixel size. And for me, this is actually 3.72. I don't know if that's a mistake in the database or possibly the difference between a Mark 1 and a Mark 2. But regardless, so now I have my telescope and my camera set, and I now have my field of view down here in degrees. Before moving forward, I'm going to go through this a second time with my Poseidon camera and my 8-inch Edge HD from Celestron. Stick around for that example as well, because there are quite a number of files that I need to download to cover my field of views, and I want to show you guys an easy way to be able to download all those files in a batch process. So for now, again, we're doing the RedCat and the Canon M50, and I have my field of view at 5.11 degrees by 3.41 degrees. So now with our field of view, we need to be able to convert those into arc minutes, because the table we're going to be referencing here in a few minutes uses arc minutes for you to be able to determine which index files you want to download. So it's real simple to do. What we just got from the field of view calculator I have up here on the screen is the Canon M50 with the RedCat. So my field of view again is 5.1 degrees by 3.4 degrees. To convert the degrees to arc minutes, 1 degree equals 60 arc minutes. So we're going to take our largest field of view, which in my case is 5.1, multiply it by 60, and that gets me 306 arc minutes. That's my largest field of view. For our smallest field of view, we need to figure out just 20% of what that is. Smallest field of view is 3.4 degrees. So we're going to take 20% and multiply it by 3.4. And then multiply that by 60, and that leaves me with 40.8 arc minutes. So now we have the information that we need when we get to the point that we need to download our index files. So we're going to start by downloading the plate solving software. That is over at adgsoftware.com. I'll leave this link in the description as well. So underneath installation, step number 1, download the installer. So just click on that link there, and once the download is done, we're just gonna run the file. We're gonna leave all of our defaults here, and it's important that you do, because there is no configuration needed in Siril. It will simply look to see if this is installed, and if it sees it, you'll be able to use it. So highly recommend you leave it in the default installation directory. So I'm gonna click next. Port number, leave that at 8080, unless you know for certain you have some other software on your computer that's utilizing that port, then you could change this here. We're gonna leave it at the 8080. And then hit install. And once the installation is finished, you'll be prompted with this dialog here. Obviously, we want start AN server selected. This will actually drop a shortcut in your start menu, so it'll run every time you reboot your computer and Windows loads. The second one is to run the Astrometric Index Downloader, which we're going to do right now. And then we're going to cover another way of downloading more up-to-date files afterwards. But for now, we're going to leave these two boxes checked, hit finish, and it'll bring up the Index Downloader. This is where we worked out our math for our field of view. The first one is asking us for our narrowest field, which is the 20% of our FOV. When we did the math, it was 40.8 arc minutes. So we're going to look to the right of these index files and look for a range that covers the 40.8. In our case, it would be index 4208. And now the second box is for our widest field, which we determined to be 306 arc minutes. So we're going to come down and again, find the range where 306 lands. And in this case, it's index 4214. All you got to do now is hit start. A command window is going to open up and you'll watch all the files download to your local hard drive. Depending on the number of indexes that were required per your selection, you could have less or you could have more files downloaded. So it's going to be different depending on your field of view settings. Okay, once that window closes, then all of your index files have been downloaded. The index files are stored over here in this path. I'll leave this in the description for you as well. So you can see it had downloaded index files 4208 through 4214 for us. At this point, you're done and you can jump into Siril and you can do your blind plate solving. But, and this is up to you, these files that come out of the index manager are not the latest files that they have available. They will work, and I'll say it probably will work, 95% of the time for everybody, but they're not the latest. If you have problems with them and they're not plate solving, then you're going to want to go out and grab the latest ones that they have. Unfortunately, there's no automated way of doing that. You have to go and download them manually and then copy them over into this folder here. So let's take a look at how to do that. We don't need the index manager open anymore, so I'm going to close that. If we come over to astrometry.net, and again, I'll leave this link as well in the description. And under the getting index files, they have, first thing I want to point out is they have an example here of how to determine which files to download. There are some typos in this documentation. If you go through here and it says, right here's the first one, referring to the table below, you should grab index files 5203 through 5209. If you look at the table, here's 5203, 4, 5, 6. There is no 7, 8, and 9. It jumps into the 4100 series index files. So we have two of them here. We have 4100 and we have 5200. But I just wanted to point that out. That can be a little bit confusing when they're telling you to download this range and it doesn't relate to the table correctly. So the second thing I noticed with the 5200, you can see it's dash asterisk, and we'll get into that more later. The 4107 dash asterisk should not be there. That's a typo as well. It should be just like the rest of them. It should stop at 4107. So just want to point that out. But for now, we're here to reference this table to grab the updated files that we just downloaded through the index manager. So again, just like we did in the index manager, we're going to reference our field of view that we calculated previously. So our smallest is at 40.8 arc minutes. So looking at the table, I want to find where that 40.8 would fall, which is right here with 4108, and all the way up to 306, which would land us here at 4114. Now we have the range index files that we want to download. If you scroll back up to the top here and click on data.astrometry.net, it will take you to where you can download those files. You can disregard everything below the additional index files down through here. We're just going to be dealing with these two up top. And these are the two series that they recommend most of us use. So again, according to the table, we need 4108 through 4114. So that's our 4100 series. So we would come in here and download 4108 through 4114. Just by clicking on each of them, we're just going to let them drop into my downloads folder. All right, and once your downloads are complete, you can see I have all the FITS files, 4108 through 4114. We're just going to group select these. I'm going to cut them from the downloads directory, and I am going to paste them into our data directory where the index manager downloaded the older files. While we're in here, you also want to remove the 4200 series that the index manager downloaded. Again, these are older files than the ones that we just manually downloaded, so we don't want the plate solving engine to use these index files. So simply delete them, and now we're ready to go. So we've got the most up-to-date index files downloaded for the plate solving software. Like I mentioned before, there's nothing more that you need to do. Siril will see that you have this installed, and it'll just work out of the box. There's no configuration you need to mess with. I'm going to open up my Rosette Nebula from last year. So I use that with the Red Cat and the M50. We'll just give it an auto stretch so everybody can see it. So here's the first use case for a blind solver, right? You've taken an image, you've used a DSLR, or you've used a mirrorless camera, and there is no rate ascension and declination coordinates for it. This image has not been plate solved. Siril does not know how to do anything with it at this point. And you know this if you've been using Siril for a while, when you go to do your photometric color calibration. So if I come up into PCC, rate ascension, declination, they're all zeros, right? What we've all been doing at this point is punching in the catalog number for the object that we want to color calibrate, hitting find, and then selecting it under the resolver name, and they're off and running. With the blind solver, if you didn't know the catalog number and you didn't want to go searching for it on the internet, with the blind plate solver in place, you have another option. So we're just going to close this out. We're going to come over here to our burger menu, image information, and image plate solver. Right here, tick use local astrometry.net solver. That's what we just installed the software for, along with the index files. At this point, all you need to do, ensure that your focal length is correct. In my case, 250. Doesn't have to be exact. The plate solver will actually computate that for you, even if it's a little bit off. And my pixel size, 3.72. And we'll probably see this change once it plate solves, but that's fine. So ensure focal length and pixel size is correct, and then hit OK. And you can watch it over here on the console. So it's going through the index files that we downloaded, and it has made its plate solve, which is also reflected in our image plate solve dialog box over here. So you can see we now have coordinates set up. So click our close button. Now if I come back over to image processing and go into photometric color calibration, those same coordinates have been populated for me. And now I can hit OK, and it'll do my color calibration for me. So I didn't need to specify the catalog. I didn't need to tell it anything. Just did a simple blind plate solve against the image, and it figured out what it was in the image for us and provided the rate ascension declination of the center of the image. And the other thing that it gave us is our WCS information down here is available now. So if I click on this button, now it annotates what it knows that's in the image. You couldn't do that before we plate solved it. Siril needs to know, again, what the image is before PCC works, before it can annotate the image for you. So there's the other benefit for you. Okay, so for now, I'm just going to close Siril down, and I want to go through the second example that I was talking about earlier with you guys for my Poseidon and the Edge HD, the 8-inch Edge HD. So again, I use astronomy tools to figure out my field of view for the Poseidon C, coupled with the 8-inch Edge HD. This is my field of view for that, 0.95 degrees by 0.63 degrees. And that leaves me with 57 arc minutes for my largest field of view, and 7.56 arc minutes for 20% of my smallest field of view. So same thing. And I'm going to skip over the index manager. If that's what you want to use, that's fine. Again, it's just not the latest and greatest index files. And I'm going to jump over and reference the same table that we used previously, but for our new field of view. And the reason I wanted to show you the second example here is because with this field of view, it is going to indicate to us that we need to grab some of the 5200 series files. And what's kind of deceiving when you look at the table, you see the 5200s and you assume those are single files, just like the 4100s are, but they're not. The dash asterisk indicates that there are multiple files prefixed with, in this example, 5206. So, and we'll get to that. So let's determine which files we need. So my smallest field of view is 7.56 arc minutes. So that puts me right here on 5203. And my largest field of view per our calculations is 57 arc minutes. So 57 arc minutes puts me up here. So for this configuration, we require 5203 through 5206, right? 5203 through 5206. And then 4107 through 4109. Now, another thing to keep in mind when you're doing multiple configurations like this, so you have multiple setups that you want to determine the field of view, so you can make sure you have the correct index files. Make sure that you haven't already previously downloaded any of these files. There's no sense in downloading them again. So again, come over to your data directory and use that as your reference. So we know we grabbed some 4100 series in the previous example. This one's telling me I need 07 through 09. If I look here, you can see I already have 8 and 9. So I only need to grab 4107, right? So now our selection looks like this. Now, again, 4107, easy enough. You can just come over, hit the 4100 series, select the file that you need, and download it. Easy. Where it gets scary is when you hit the 5200 series. For each of these 5 XXX indexes, there are 42 files that correlate with them. So looking at 5203, you come all the way down until 5203 starts, which is right here. And you can see that we actually have 47 files in the 5203 series. And we also need 5204, 05, and 06. That's a lot of files to be sitting here and clicking through each one individually. So there are a number of solutions out there that will allow you to batch download files in a case like this. The one that I found worked well for me, and this is why I wanted to do this second example for you guys, so you're not sitting here for a week trying to download these things. It's an extension for Chrome called Down Them All. And again, I'll leave this link in there as well. Just hit add to Chrome, add extension, watch over in the corner, it'll tell you when it's done, and we're almost ready to go. In order for this to work properly, you need to disable prompting for a download. So what I mean by that is if we come back over here, and I'm just gonna re-download 4107 or start it, right? So if I click on 4107, it prompts me, where do you want to save it? We need to turn this box off. We just want it to download. If we don't disable it and we dump all these files into that extension to batch download, it is going to prompt with this box for each and every one of them, defeating the whole purpose, right? So cancel out of that. And in Chrome, you come over here to your ellipses button, hit your settings, downloads, and then right here, ask where to save each file before downloading. You can turn that off. And if you don't like doing this, just turn it off for now. Get your index files. When you're done, come back and tick that back on. But you will need to turn this off for the batch downloading to work as expected without prompting you for anything. So with that turned off, we're going to come over and we're going to click on our 5200 series. Again, we're looking for 5203 through 5206. We're going to come over to the plugin, click on download them all. And I just use the one-click option right here. It'll bring up this box for you. What this is doing is the current page that you have open, which is the web page to download the index files, it's listing them. Everything on this page is in here. So you can either come over and put a tick box next to everything that you want to download, which again, we have quite a bit of files to download. That's too time consuming. But you can do some filtering. So we want 5203. So I'm going to say 5203, comma, 5204, comma, 5205, comma, 5206. Those are the 4 indexes per that table that we need to download. So now with that filtering in place, if you scroll down, it still shows you all the files, but it'll highlight the ones that it's going to download. So there's our 5203 series, 5204, 5205, and 6. Everything else, if it's not highlighted, it will not be downloaded. So now with everything selected, highlighted, and tick boxed, right? You can see the checkbox on the left-hand side there. Just click on download. It'll come up in another web page and it'll show you the progress. So this is obviously going to take a while. We have, if you look in the tab here, 192 files that it's downloading. So we're going to let this finish. And when it's done, we'll come back and move them over into the proper directory for the plate solving server to use. So now all of our index files have been downloaded as indicated by the green bars going across the screen here. We're going to come over into our downloads directory and do the same thing we did last time. We're going to cut these files out of my downloads folder and put them where they need to be for the plate solving server. So just do a group select, hit my cut icon over into the data directory, and then paste. So now I am currently configured for both of my systems, the Red Cat with the Canon camera and the 8-inch Edge HD with my Poseidon C. So let's go back into Siril and do some testing. This time I'm going to open up my Ghost Nebula and we'll do an auto stretch. And because this was shot with the Poseidon camera, if we came up to our color calibration, we don't have a need to plate solve. At least it appears that we don't have a need to plate solve. Our rate ascension and declination coordinates are already in place for us. But sometimes what happens when you try to do your photometric color calibration, we'll click OK here. This just so happens to be an issue with this image. You'll get a plate solving failed message that it couldn't match any of the stars from the catalog. This happens sometimes with the inbuilt plate solving from Siril, but having your blind plate solving engine installed here can help resolve that. So we're going to click close, and then just like before, come up to the burger menu, image information, image plate solver. We're going to make sure that our focal length and our pixel size is correct. We already have our right ascension and declination, and we're going to tick to use the local solver and then click OK. Watch over again on the console, and there we go. We have our solve. So now if I click close and then come up to image processing and color calibration, photometric color calibration, and then click OK this time, it'll actually succeed for me. So you can see it color calibrated once we ran it through the plate solver, even though it failed the first time around. And again, we can come down here and annotate our images, and it'll show us the objects that it's solved in the image. So there you go, local blind plate solving within Siril. It's a pretty cool feature. I want to take a moment to thank everybody that's joined my membership programs here on YouTube and on buymeacoffee.com. Appreciate everybody's time watching the videos. If you're not a subscriber, consider subscribing, give the video a like and share. And until next time, we'll see you on the next video, and clear skies.